How do we differentiate parametric equations? Okay, so we know that there is a parameter, as we explained in the last video, and we understand that we have the y dx. We have to evaluate also the square y dx squared. Okay, so therefore this is the formula for the y dx, which is the y d theta divided by dx d theta. And when we want to go further in evaluating the square y dx squared, we are going to say the d theta of dx dy divided by dx d theta. So let's take an example so that this doesn't look abstract to us. 1. Given that x is equal to 5 theta minus 1 and y is equal to 2 theta in theta minus 1, evaluate the y dx. Now we understand that the y dx is the y d theta divided by the theta, divided by the x d theta. So therefore we have to evaluate the y d theta and also evaluate the x d theta. Now since y is 2 theta into theta minus 1, let's open the bracket. So this will give us 2 theta squared minus 2 theta. Therefore we can evaluate the y d theta. Evaluating the y d theta will give us 4 theta minus 2. 4 theta minus 2. X now, which is 5 theta minus 1. We can evaluate the x d theta, and this will give us 5. So from the formula that says the y dx is the y d theta divided by the x d theta. The y d theta is 4 theta minus 2 and the x d theta is 5. So we can simplify further to factorize 2 in the numerator. That will give us 2 into 2 theta minus 1 divided by 5. So this can be the y dx in terms of theta can now be written as 2 over 5 into 2 theta minus 1. So based on the formula given, we can evaluate the y dx. Let's take another example. The parametric equations of a function are given by y is equals to 3 cos 2t and x is 2 sine t. We are asked to evaluate expressions for a, the y, the x, and b, the square y, the x squared. We recall that the y, the x is the y. Now this time we are using the parameter here is t. That's the y dt divided by the x dt. And the square y, the x squared, will be d dt of the y, the x, divided by the x dt. So you can pause the video now and give this a trial. Let's begin with the y dx. The first thing we are going to evaluate is the y dt, likewise the x dt. Now applying the differentiation of cos 80, remember that when we differentiating with respect to t of cos 80, we are going to have minus a sine 80, and differentiating again with respect to t of sine 80, we are going to have a cos 80. Therefore, this will give us 3 into 2 minus 2 sine 2t, and that will give us minus 6 sine 2t, and the x dt, that means differentiating 2 sine t, we will have 2 cos t. Now let's apply the formula that the y dx is equal to the y dt divided by the x dt, and our dy dt is minus 6 sine 2t, and our dx dt is 2 cos t. Can we simplify further, or should we just leave our answer like this? We can also apply trigonometric identities to reduce this further. Now, in trig identities, sine 2 theta is the same thing as saying 2 sine theta cos theta. Therefore, sine 2t is 2 sine t cos t. This is gotten from double angles. Double angles formula. Now, if sine t is 2 sine t cos t, therefore we can substitute this to give us minus 6 multiplied by 2 sine t cos t divided by 2 cos t. Evaluating further, we have finally that our dy dx will give us minus 6 sine t multiplied by 2 cos t divided by 2 cos t. Therefore, our dy dx is minus 6 sine t. Now let's go again and try and differentiate d square y dx squared. D square y dx squared. What is the formula to getting this? That is d square, or sorry, d dt of dy dx divided by dx dt. Now let's look at what we have and what we don't have. We have dy dx, which is minus 6 sine t. We also have the x dt that we got here, the x dt to be 2 cos t. Now, from the formula, we are asked to evaluate d dt of dy dx. d dt of dy dx. Now let's substitute our value of dy dx. That is d dt of minus 6 sine t. That means we are asked to differentiate with respect to t of minus 6 sine t, and this will give us minus 6 multiplied by d dt of sine t. Now differentiating sine t, we will have cos t, So this will give us minus 6 cos t. Therefore, our d square y dx squared is equal to minus 6 cos t divided by 2 cos t, because our ddt of the y dx is minus 6 cos t and our dx dt is 2 cos t. Now this is equal to minus 3. In conclusion, our dy dx is minus 6 sin t, and our d square y dx squared is minus 3. Now these are methods of differentiating parametric equation. In the next video, we will talk more. We will take another example to differentiate parametric equation.